Okay, in this video, we are going to look at how we can make sure that our Simulink environments runs at a fixed solver time, or that it is always solving at a fixed time. So what you need to do is like modeling, go to model settings, and under the model settings, you need to have some settings that allows us to like make sure that it is running at a fixed step time. So you need to change the solver selection to fixed step as well as discrete no continuous states, and just put in the period that you need. So right now uh, it's running at 2000 hertz because it's 1 hour. 2000 gives you this value. Okay, so how can we verify this? To verify this one, what you can do is like you can use the clock block. So you can call the clock. This is interesting. So you can like view the time, right? So view the time, have display, you can use the display, right? So pass the clock value to the display and just run it. When you run it, it gives some value, right? 1 point something, but doesn't give you any valid result yet, right? So also it has this display time decimation after 10 uh, 10 maybe like iterations, it will output. So right now if let's say that we need to update the time every 1 second, as our frequency is 2000, you just need to put 2000, right? Decimation, apply, and okay. If you put 1, it will be 0 0.00 uh 05, right? Okay, now let's put this one. So right now, can you see it's this display icon updates every 1 second, but it does not change anything regarding the time that it outputs. It's continuously doing that. But decimation 2000 means like it updates this thing every 2000 units or iterations. So if we put 0 point, we cannot put 0 0.0 because this is like an integer number. So if we put 1, it means that this will update every 0 0.0005 seconds, right? That is the unit time. So that is what we are seeing here. But let's say that we need to verify this result. So what you can do is like whether this is actually happening, what you can do is like you can introduce a delay unit or something like that. We have something delay, I think it's unit delay is a delay by 1 unit, right? So if we delay this by 1 unit, what happens is like so this output will be lagging 1 unit, right? So we can maybe add an add block, add, and we can subtract 1. So subtract 1, we minus current time. Let's minus subtract the current time and the old previous time, and now we can add a display here. Okay, so if I do all that and if I click run, you should see this value is fixed, right? Because now actually it is running at uh, so 0 0.0005. We can convert this easily to frequency if you want to. How can we do that? We can like maybe get the time derivative, right? Maybe how yeah, I think it will work. Mm, let's see, derivative. Hope this works. Derivative here. I think no, no, it doesn't work. We have to take 1 or something, right? So maybe multiply this with uh, gain. Gain, yeah. Let's put a gain. What do we mean by derivative in this case? I don't know. Let's add a gain. Okay, gain of one. Uh, gain of what? Mm, not one, right? Should be one over whatever the signal, right? So, mm, how can I do that? If it is multiplied by 2, that's not a problem. But no, uh, we uh, so this is giving me the time. So yeah, yeah, gain. So so uh, 1 over the 1 over t is f, right? F is equal to 1 over t. So 1 over t. So we are getting t. Take 1 over. 1 over means again actually. We need to get what? Inverse. Inverse? Is it inverse? Inverse. One. What is that called? Uh, so I did a bit of research and the exact term is the reciprocal. I need to have the reciprocal. Procal. Okay. Reciprocal. What is this? This one here and run. What happens now? Okay, now we see 2000. But I was still wondering about the derivative. So in this case, what does derivative mean? Like if we take the derivative, what happens? Each 0.005, if we take the derivative, will it be 1 for the original signal? Let's see. I don't know. It's not 1. Our problem is solved, but out of curiosity, let's take the derivative again. So here the small derivative means like this subtraction actually, right? It's the difference between two things, I believe. So it should be giving us the same value, right? Uh, hmm, take derivative in this case means the change, right? Change is 1. Yeah. Mm, okay. 1. Yeah. Maybe derivative is 1. Maybe that this is computing everything. Delta t is like per second or something. Yeah. So this is how we verify anyway. I got it as 2000. That's what I need. Okay.